Good morning, ma'am. I'm K. Teja, studying third year mechanical in SRAT College. I'm here to say a few words about plasma arc machining and its equipment advantages and disadvantages. First of all, before going to the plasma arc welding, we should know what is meant by plasma arc machining. Plasma arc machining is a thermal cutting process that uses a high velocity plasma jet to cut through electrically conductive metals. It means it uses a thermal cutting process that which uses high velocity plasma jets to cut conductive materials. This is known as plasma arc machining. It is widely used in industries such as aerospace, automotive, and fabrication for precision cutting. PAM offers, that is, plasma arc machining offers, high speed versatility and ability to cut complex shapes. Here we can able to see the diagram of the plasma arc welding. It uses a tungsten electrode and produces high velocity plasma which cuts the workpiece into required shapes. Principle of plasma arc machining operates by creating a constricted arc through ionized gas plasma that melts and blows away material. An electrical arc is generated between a plasma torch and the workpiece, which is then rapidly cooled to maintain the plasma state. The process involves transferring electrical energy into plasma energy, which reaches the above temperature, that is 30,000 degrees Celsius. This is the most boiling temperature of the plasma. Components of plasma arc machining. The main components include powder supply, plasma control system, and gas supply unit. Here we can able to see the components of plasma: shielding gas, water cooled nozzle, weld pole, workpiece, and power supply. Types of plasma arc machining. There are two primary types. One is transferred arc and other is non-transferred arc systems. Transferred arc system generate plasma directly between the electrode and workpiece. Non-transferred arc generates plasma between electrode and the nozzle, which that can be transferred into workpiece. The process begins with establishing electric between the electrode and the workpiece. Negative source is connected to the tungsten electrode and positive source is connected to the workpiece. Ionized gas is expelled through a constricting nozzle which creates high temperature plasma jet. The plasma jet melts and vaporizes the material which is then blown away by the high velocity gas stream. Materials suitable for plasma arc machining, that which for which materials we can do plasma arc machinings, that we can know in this slide. Plasma arc machining can cut a wide range of conductive materials such as steel, aluminum, copper, and titanium. It is especially used for cutting thick metals and materials with complex shapes. Non-conductive material non-conductive material cannot be directly cut by PAM because they cannot conduct electricity and plasma cannot cut these materials. Advantages of plasma arc machining. Plasma arc machining provides high cutting speeds and precision for complex geometries. It produces minimal thermal distortion and a clean edge finish. The process is highly versatile, capable of cutting various materials and thicknesses. Limitations of plasma arc machining are: this process may cause oxidation or thermal stress in the workpiece. Skilled labor is required to perform this operation. It generally has higher operational costs due to power and gas consumption. It is less effective for very thin materials which may be prone to warping. Applications of plasma arc machining. PAMUS is used in aerospace for cutting, shaping aircraft components. It is employed in the automotive industry for manufacturing engine parts and body panels. The process is also used for scrap removal and surface finish in the repair work. Comparison with other cutting processes. Compared to oxy-fuel cutting, PAM offers cleaner cutters and is suitable for thicker materials. Unlike laser cutting, PAM cut conductive materials without focusing optics, but with less precision. Plasma arc machining is faster than traditional machining, like grinding or milling for certain tasks. Safety measures in PAM. Operators should wear protective clothing, gloves, and eye protection to protect their body from the oxidation and UV radiation. Proper ventilation is necessary to avoid inhaling harmful fumes and gases. Regular maintenance and inspection of equipment help prevent electrical hazards and ensure safety. Future trends in plasma machining. Advances include im- Advances include improvement of torch designs for higher efficiency and precision. Integration with automation and CNC system enhances productivity and accuracy. Maintenance and troubleshooting. Regular cleaning of torch nozzle and electrode prolongs equipment life. Troubleshooting common issues like arc instability. The control system ensures consistent of code quality and operational safety. And summary of key points are plasma arc machining is very fast, versatile thermal cutting process for conductive materials. It relies on high temperature plasma jet that is generated by an electric arc. It applications spam manufacturing, repair and surface treatment industries. Thank you.